Welcome to this video tutorial to AppJangle. In this tutorial, I'll expand on the example developed in the previous tutorials and demonstrate the performance of the AppJangle engine in batch processing and caching. I'll start with the Java application, which will run 4 quick experiments. In the first experiment, I'll simply create a seed node. This operation takes about a second to execute. For the next experiment, I create a few employee records. This only takes a few milliseconds, since all new records are created in the local data replication. Synchronizing these changes with the cloud then takes a bit longer, since messages need to be exchanged with the remote cloud. However, reading the employee records locally can again be done in near real-time speed. Since the AppJangle engine can read from the replication in local memory rather than having to request it over the internet. To illustrate the performance of loading records from the cloud, I'll develop a few more experiments in JavaScript. This time I'll create an HTML page hosted on the AppJangle cloud. For this, I can use one of the applications provided on the AppJangle platform. I paste some code to load the employee records created by the Java app. I can run this app by clicking on the link generated for this page on the AppJangle cloud. This takes longer than loading the records from the in-memory storage. But I can use a special type of session which utilizes HTML5 local storage to speed things up. When I run this revised app for the first time, it takes around the same time as before. But when I run the app for a second time, it will load much quicker using the persisted local storage as a cache. These demonstrations show the 3 tiers of performance available to AppJangle applications. Operations which depend on new data from the cloud usually take half a second to 5 seconds to execute. Using the local cache, it's 100 to 500 milliseconds. And using the in-memory replication usually takes only 20 to 50 milliseconds. The AppJangle engine automatically chooses the best option for operations, all transparent under one common API.